Morning students. In this video we are going to discuss about handling multiple devices and interrupt nesting. What actually and multiple devices? Well, handling and different IO devices, the issues are going to be get concerned over there. Let us discuss about how can the processor recognize the device request and interrupt. How can the processor obtain the starting address of the appropriate interrupt service routine? How should a device be allowed to interrupt the processor while another interrupt is being served? How should two or more simultaneous interrupts request may be handled? So these are the queries which is going to be presented over there. Let's we discuss about that. Multiple IO devices can be connected to your processor and the memory via a bus. Some of all of these devices may be capable of generating interrupt requests. Each device operates independently and hence no definite order can be imposed on how the devices generates the interrupt request. So if two interrupt requests are received simultaneously, then how to break the tie? So simply we're going to consider a arrangement where all devices sends the interrupt request over a line, over a control bus. When the processor receives an interrupt request over this control line, the information is available in the status register of the input device requesting an interrupt. The status register of each device has an IRQ interrupt request bit which is set to 1 when it requests an interrupt. The interrupt service routine can poll the IO devices connected to the bus. The first device with IRQ equals to 1 is the one that is served. The polling mechanism is easy, but the time consumption to encode the status bit of all the IO devices connected to the bus. So let us see a simple configuration over there. So yeah, multiple devices are going to be connected over the device 1, device 2, device 3, like the device P. And each and every devices are going to be connected to an interrupt request line, separate interrupt request line, and a separate interrupt acknowledgement line. Such a way it's going to be called as interrupt nesting. Let's see how it's going to be get processed. A device requesting an interrupt may identify itself directly to the processor. A device can do some special sending a special code 4 to 8 bit the processor over the bus. Copied, the code is going to be supplied by the device, can represent a part of the starting address of the interrupt service routine. So the remainder of the starting address is obtained by the processor based on the other information such as the range or a range of memory address where the interrupt service routine are located. Usually the location pointed to by the interrupting device is used to store the starting address of the interrupt service routine. Previously, before the processor started executing the interrupt service routine for a device, it is disabled the interrupt from the device. In general, same arrangement is used when multiple devices can send interrupt request to the processor. During the execution of an interrupt service routine of a device, the processor does not accept interrupt request from any other devices. Since the interrupt service routine are usually short, the delay that is caused is generally acceptable. However, for certain device, this delay may not be acceptable. Which device can be allowed to interrupt a processor when it is executing an interrupt service routine or another device? Yeah, the IO device are organized in a priority structure also. Let's discuss about that, how actually it's going to do its process. uh, we use an register in the keyboard or a display. A polling is going to be a process where the information needed to determine whether device is requesting interrupt is available in the status register. So here the data display, nothing but some few codes we are going to follow over there. There's nothing but DIRQ, nothing but interrupt request for display, interrupt request for keyboard, interrupt enable, keyboard display key enable, signal flags. For an input device, when an signal in status flag is used, when signal in status flag is 1 when a character is entered into the keyboard, whereas signal in is 0 when the character is read by the processor. Such a way, the IRQ is going to be when a device raises an interrupt request. So with the help of this data in and data out register, as well as the status register where this DIRQ and KRQ, SO out, SIN are the control signal DEN and KEN. Based on this bits, this processor is going to come to know about that where actually the interrupt is going to be requested, and that is going to be get satisfied by the particular processor. Let's see about the advantage and disadvantage of this particular interrupt. Multiple handling interrupts. Multiple interrupts handling. Advantage, it's very simple and easy to implement, whereas disadvantage, more time is going to be spent on pulling the IRQ bits of all devices. So there we are going to have a problem with this particular multiple handling interrupts. So we are going to see about another arrangement how actually it's going to get processed. So to do that one, we have to go for a next topic called as vectored interrupt. Vectored interrupt. A device requesting an interrupt identifies itself by sending a special code to processor over a bus is going to be called as vector interrupt. So here we're going to say that the processing technique in which the interrupting devices directs the processor to the appropriate interrupt service routine, that is going to be called as vectored interrupt. This is constrained to an pooled interrupt system in which a single interrupt service routine must determine the source of the interrupt by checking all the potential interrupt sources, a slow and relatively laborious process. Vector interrupts are achieved by assigning an each interrupting device a unique code, typically as I said 4 to 8-bit length. When a device interrupts, it sends its unique code over the bus to the processor, telling the processor which interrupt service routine to be get executed. Based on that, the processor starts executing the ISR. The special code indicates the starting address of ISR. The code length ranges from 4 to 8 bits now. The location pointed to by the interrupt device is used to store the starting address of the ISR. The starting address of ISR is called as the vector interrupt or interrupt vector. The processor then loads the interrupt vector into a program counter and executes the appropriate interrupt service routine ISR. When processor is ready to receive an interrupt vector code, it activates the interrupt acknowledgement line. Then the IO device responds by sending its interrupt vector code and turning off the INTR signal. Then the interrupt vector also includes a value for the process status register. Such a way it's going to accept the interrupt and it's going to process for the particular interrupt process.